In this lesson, we're going to be adding and subtracting radical expressions. In order to add or subtract radical expressions, you have to have like radicals. And that means that they have identical radicands. The numbers inside the radicals will match. So in order to do this, we will start by simplifying each radical expression individually, and then we will combine the like radicals by adding or subtracting their coefficients, keeping the like radicand the same. Okay, so let's look at example 1a. On example 1a, we have 2 radical 3 plus an understood 1 radical 3. So we need to identify our like radicals, and in this case, we have a radical 3 here and a radical 3 here. So these are like radical expressions. So we will add their coefficients. 2 plus 1 equals 3, and that will give us 3 radical 3, keeping the like radicand the same. All right, so all we had to do there was add the coefficients. That's fairly simple. Let's look at example B. If I look at the radicals here, they do not match. I have a radical 6 and a radical 24. And the radical 24 can be simplified. We could bring a perfect square out of that expression. So let's look a little more closely at that. So we want to simplify radical 24 by bringing out a perfect square factor. So don't forget your perfect squares, 1, 4, 9, 16, 25, and that's big enough. You know they go on, but 25 is too big to go into 24. 16 also does not divide evenly into 24. 9 does not, but 4 times 6 is 24. So we're going to split our radical 24 into 4 times 6, and then we can take the square root of 4, which is 2, and that simplifies to 2 radical 6. Now, our other radical did not need to be simplified because 6 cannot be divided by any of these perfect squares. So we'll just bring down our 5 radical 6, and we're ready to add. Now we have like radicands. They're both a radical 6, so we can add the coefficients, 5 plus 2, to get 7 radical 6. Let's look at example C. Here again, we do not have matching radicals, and both of these radical expressions can be simplified, so we need to make note of our perfect squares and see what we can divide into these things. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are the first 10 perfect squares. So 72, I know 181 are too big, 64 is too big to divide into there, 49 does not go in evenly, but 36 times 2 is 72. So I'm going to split 72 into radical 36 times radical 2, and I'm going to bring out the root of 36, which gives me 6 radical 2. And then I'm going to go ahead and bring down my minus sign so I don't forget it later. And now I'm ready to simplify square root of 18. So we're looking for numbers that can divide evenly into 18. 36 is too big, 25 is too big, 16 is too big, but 9 times 2 is 18. So I'm going to split that into radical 9 times radical 2, and don't forget that 4 that was in the front. So the 4 will multiply with the 3 from the root 9. And so 4 times 3 gives us 12 radical 2. So now I have 6 radical 2 minus 12 radical 2. I have the same kind of radicals, so now I can subtract them. I'm going to subtract their coefficients. 6 minus 12 gives me negative 6 for my coefficient on my matching radicals. So when I subtract, negative 6 radical 2 is the answer. Let's take a look at example D. In looking at the radicands, they do not match. So we can't go ahead and add them. We'll need to simplify each of them. I've already written my perfect squares over here to the right, and 25 is too big to divide into 20. 16 is also too big. 9 is too big, but 4 times 5 is 20. So I'm going to split the 20 into radical 4 times radical 5, and I'll bring out the root of 4, which is 2, giving me 2 radical 5. I'm going to go ahead and bring down the minus sign here, and then I'm going to simplify radical 80. So let's look over here to the right, and 81 is too big, 64 is too big, 49 is too big to go into 80. 36 also does not divide in evenly, 25 does not divide in evenly, but 16 goes into 85 times as well. And you can kind of get a hint there that if this first one is divisible by 5 and gives you a perfect square factor to bring out, the other one might also be divisible by 5. So we're going to split the 80 into radical 16 times radical 5 and bring out the root of 16, which is 4, giving us 4 radical 5. Now we have like radicands, and we can subtract our radical expressions. So we'll subtract their coefficients. 2 minus 4 is negative 2. So we end up with negative 2 radical 5. Remember that you are keeping that like radicand you had right here and right here in your final answer as well. So we have a couple more challenging problems for example E and example F. So example E, we're going to be adding and subtracting with 3 radical expressions instead of just 2. And they all have different radicands, so we're going to have to be looking at each of those individually. Let's get rid of these things, and let's look at the radicands here. So our first one has a radical 2, and that cannot be divided by any perfect squares, so it's already in simplest radical form. And then our second radical expression is 1 radical 5, and radical 5 also does not divide by any perfect squares, so it is in simplest radical form. We'll look at our third radical here, which is radical 8, and we want to ask ourselves what perfect square divides evenly into 8, and that is 4. So we're going to bring down our negative 7, and we're going to split that 8 into 4 times 2. Radical 4 times radical 2 equals radical 8. And then we're going to take the root of 4 and multiply it with that 7 that's already out in the front, giving us negative 7 times 2, radical 2. And then finally we're going to multiply those to give us negative 14, radical 2. Now those other two expressions that we started with, they didn't need to be simplified, so we're just going to bring them down so that we can work with them. So we have 3 radical 2 here, plus radical 5 here, and then we'll be subtracting 14 radical 2. So which of these two radicals can be combined? It's the ones that have the matching radicands that we can add or subtract together. So the matching radicals, or the like radicals, we can combine their coefficients. So 3 minus 14 gives us negative 11, radical 2. And then that other radical that did not have a like radicand, we'll just bring it down and add it to the end. So plus radical 5. All right, here's our last example in this set. And I can see that with my radicands, none of them match, and they can all be simplified. So I'm going to start there. I'm going to ask myself, what can I divide 40 by on the list of perfect squares? 36 is too big, 25 is too big, 16 is too big, 9 is too big, but 4 times 10 is 40. So I'm going to write down my coefficient of 9 and split my radical 40 into radical 4 times radical 10. I'll take the root of 4, which is 2, and multiply it times the 9 outside of the radical. And that is going to give me 18 radical 10. So I've simplified my first radical expression, and now I'm going to bring down my minus sign and work on my second radical expression. So I have radical 300 there, and radical 300 is clearly divisible by 100. 100 times 3 is 300. So I'm going to split that radical 300 into radical 100 times radical 3, and I'm going to bring that down as 10 radical 3. Take the root of 100, which is 10, and bring it out to the front of the radical. And now I will bring down my next minus sign, and I'll start working on radical 90. So radical 90, I'm going to look over here. 100 is too big to divide into 90, so is 81 and 64. 49 does not go into 90. 36 does not go into 90. 25 doesn't. 16 doesn't. But 9 times 10 is 90. So I'm going to split radical 90 into radical 9 times radical 10. And I'm going to take the root of 9, which is 3, and bring it outside, so that gives me 3 radical 10 for that radical expression. Now I have 3 radical expressions. We're subtracting. 2 of them have like radicands, so those are the ones that I'm able to combine. So I'm going to subtract their coefficients. 18 minus 3 is 15. Radical 10. Remember that you keep the matching radical with your answer. And then I have this third radical, which does not have a matching radicand, and so it cannot be combined, but it doesn't just disappear. I just write it down, minus 10 radical 3, at the end of my expression. And that's my answer. Now, you're ready to practice adding and subtracting radical expressions on your own. Good luck!